LeBron and Trina are talking about our sun and other stars. Trina argues that the sun is much larger than all the other stars in the sky. She explains that most of the other stars are about the same size as each other and the same distance from the sun. LeBron disagrees. He explains that the sun looks larger than the other stars because it is closer. He also argues that the other stars vary a great deal in size and distance from the Earth. Who is correct? Explain your answer. I think that LeBron is correct because all of the stars they are all different sizes, different brightness, and a different farness away. Like in this picture here, it shows that near is brighter than far away. When stars get farther away, they get duller. But they still are bright, but they just don't look as bright because they're not as close. Um, that's why the sun looks so bright. Like here, it shows that like red, see it goes up and down, is not as bright. It's only like 3,000 degrees on the surface. But then it goes to yellow, which is like a little bit brighter, hotter, which is 6,000 degrees, and then whitish blue is about 10,000, and dark blue is 30,000. So blue is so hot. But red, it's still really hot, but not as hot as blue. It just people think that red is hotter because they think of like sinks, like red is hotter water, blue is colder water. But actually, blue is a lot hotter than red is. Um, so it shows here that bluish color is above 31,000 degrees. Bluish white color is 9,750 degrees to 31,000 degrees. And the bluish is also the luminosity, which is like how bright it is 300,000. So and then the 9,750 to 31,000 is 10,000 luminosity. And then white stars are only 7,100 to 9,750, and that's only 7 luminosity. So that shows that like the bluish and the blue-white ones are just so much brighter than the white ones. And then yellowish white are 5,950 degrees to 7,100 degrees, and that's only 6 luminosity. Yellowish is only 5,250 to 5,950, and it's only got 1 luminosity. And then orange really isn't even that bright at all. It's still really bright, but it's not nearly as bright as any of these. It's only 3,950 to 5,250 degrees, and it's not even 1 luminosity. It's 0.4. So that's just like so much smaller than the bluish one. Then reddish is only 2,000 to 3,950 degrees, and it's 0.06 luminosity. Like that just shows how bright these bluish ones are compared to these ones. So like if we go back here, the sun, it's right here. That's yellowish white, and and then on this one, the yellowish white only 6 luminosity, but then these blue ones up here are they were 300,000 luminosity. So that's like 300,000 more luminosity than the sun is. So blue ones are way brighter, but it doesn't show that because they're so far away. Like it shows here, near is brighter, and the sun is so much closer than the bluish ones. So that's why the sun looks brighter and bigger because it's so much closer. But really, these ones are the blue ones here are a lot brighter and a lot hotter.
Sometimes you can't drag this in. You can only drag this in.
The larger of two stars with the same temperature at the same distance is brighter.
So that's fine. So you just save it.
So this one's brighter, because because it's a larger star. Then they're the same color, they're the same distance away, and they're the same amount bright. but this one looks brighter just because
Wait,
it's
so it looks
bigger.
brighter.
Like, when they look bigger, sometimes they appear brighter just because there's more glow in them.
Can you help other kids when you guys
That's
get a chance?
about
Some
it.
kids are really stressing.
I'll do that.